Hello students. Student, in the previous class just we have to finish the lecture number 1, chapter number 1, that should be related to the relation and function. So in this particular unit, student, there are two chapters are to be included. So today we are going to start the next and very important chapter that should be named as the inverse trigonometric functions. So basically student, here the three words are to be included in this particular name of this chapter: inverse, trigonometric and functions. Student, in class 11 or in the previous lecture, just we have to define the particular type of functions, and basically on the behalf of mapping, just we have to categorize the basic functions like one, many one, on to, into, and also we have to just do the calculation for the inverse of a given function. Is it to be clear? So today student, that particular concept of chapter number 1 we will also use in this chapter number 2, but before that we have to just know the meaning of each and every term that should be used in this chapter: inverse, trigonometric and functions. So basically you can say that in the case of this particular chapter, there are three words: inverse, you can say that second word is named as the trigonometric, and the last word is to be used as function. So basically student, first of all you can just define the function. What should be the meaning of function? So for the definition of function, you can just say that it is a special kind of relation. It is a special kind of relation whose in which the basic particular domain element has exactly one image in the codomain. Then that particular type of relation is said to be the function. So you can say that it is a special type of relation. You can say that it is a special type of relation in which domain, in which you can say that domain element has exactly one image, has exactly one image in codomain, one image in codomain. Is it to be clear? So basically this particular definition will specify what should be the function, and we have also discussed about the particular graphical definition, means how the particular graph is to be checked whether it will represent a function or not. Then we are saying that we are just drawing any line parallel to y-axis. Suppose any line parallel to y-axis intersect the given curve at the exactly at one point, then it is said to be the function. And suppose that line will intersect the particular curve at more than 2 points, then it is not said to be the function. So first of all, we just have to know about the basic definition of function. And student, in the last lecture or in class 11, just we have to discuss the basic definition of functions, and where we have to just discuss various kind of different type of functions, like on the behalf of mapping, you can say that one function, many one function, into function, onto function. Is it to be clear? So all these type of functions on the behalf of mapping we have already discussed in the chapter number 1, relation and function. And student, in class 11, some definition based function we have already discussed in the class 11, like you can see that modulus function, greatest integer function, signum function, trigonometric functions. Is it to be clear? So basically, first of all we have to just know about the basic meaning of this particular word function. What is the function? Next word is to be used as the trigonometric. So basically student, in the case of trigonometric, the various kind of trigonometric ratios we have to define in the class 11, where we have to just use the right angle triangle where the three sides are to be there, hypotenuse, perpendicular and base. So according to the particular function, like sin x, cos x, tan x, like these functions, we have to use the some trigonometric ratios. So that particular trigonometric ratios are to be defined as the trigonometric functions. So here you can just say that there are total number of 6 type of trigonometric functions we will discuss here. One is known as the sin x. Then you can say that next one is known as the cos x. After that we will discuss about the tan x. Then after we will discuss about the cot x. After that sec x and cosec x. So here just we have to find the inverse of these 6 trigonometric functions. So I think student, each and every student know very well about the name of these trigonometric functions, like sin x, cos x, tan x, cot x, sec x and cosec x. And student, you have already discussed about the particular graph of that functions. So we will again just discuss the graph, and according to that we have to just calculate the domain, range, each and everything we will just know after drawing the graph related to the given function sin x, cos x, tan x, cot x, sec x or cosec x. Is that to be clear? So these are the 6 trigonometric functions. Just we have to see first of all, then after we have to just convert these trigonometric functions into their inverse part, means how the inverse will be existed. Is that to be clear? Now the third word that should be used here, inverse. So student, if any inverse is to be get obtained for any given function, then we have to keep in mind a very important definition of inverse. That should be, if any of the function that should be 1 1 and on 2, means it should be bisective, then their inverse will be existed. Otherwise no inverse of any trigonometric function or any other function will be obtained. So inverse, you can say that this particular line is to be very important here. Inverse of any function, inverse of any function exists only when only when it is bisective. It is bisective, or bisective means you can say that the function should be 1 1 plus on 2, 1 1 plus on 2. Is it to be clear? So basically student, in this particular chapter inverse trigonometric functions, we have to just see the each and every part carefully, because here the function definition should be clear first of all. Then what type of trigonometric functions we will just discuss here. So we have to know about the name of these functions, as well as how the particular inverse is to be get obtained. So for this part we are saying that inverse of any function will be existed only and only when the given function is said to be bisective, or you can say that it is 1 1 plus on to both. Is it to be clear? Then their inverse will be defined here. Is it to be clear? So student, one by one we will take the trigonometric function. First of all, just we have to see the basic graph of that function. After that we have to just check whether it is its inverse will be possible or not. So basically each and everything we have to see carefully, and after that we have to just say, suppose the function is said to be the bisective, or you can say that 1 1 and on 2, then definitely we will just calculate the inverse. Student, inverse means we have to just follow the definition of inverse also. Suppose any function f is to be defined from x to y, suppose fx, and suppose fx is said to be the bisective, then there exists a function g y to x, where g of y equals to x is said to be the inverse of the given function fx. Is that to be clear? So we have to just keep in mind the definition of inverse always, because such type of definition student already we have discussed in the last previous lecture, relations and functions. Is that to be clear? So one more important thing we have to keep in mind. Just pause the video to note it down the these things. Then next part we are just saying that student, definition of inverse. You can say that definition of inverse. So in the definition part of any inverse function, what we are saying, let f is any function defined from x to y, and fx is said to be bisective. Fx is said to be, or fx is a bisective function. Fx is a bisective function. Fx is a bisective function. Then there exists a function g. There exists a function g defined from y to x such that g of y equals to x. Here any function f of x equals to y is to be get defined here, and here this fx is a bisective function. Then there exists a function g that should be defined y to x. It is to be defined from x to y, and it should be defined from y to x such that g of y equals to x. Then g is said to be inverse of fx, and it is represented as f inverse of x. Is it to be clear? So the basic definition of inverse we have to just keep in mind because these type of definitions, student, already we have discussed in the last lecture, where we have to just calculate the inverse of any of the function. Then how the inverse will be there? Then there will be two concepts we have just read in the last lecture. One is related to the composition of function, where we are saying that f o g x or g o f x, suppose both the functions are said to be the identity function, then definitely g is said to be the inverse of f. Or in other language, we can say that if any function fx equals to y and x is to be defined, f function is to be defined from set x to y, and suppose it is said to be the bisective, because just we have to calculate the inverse only in that case whenever the function is said to be bisective. So then there exists a function g that should be defined from y to x such that g of y equals to x. Just we have to convert the things, means initially the things are to be written like y is to be written in form of x, then we have to just convert. Now x is to be converted into the y form, so this is said to be the g of y equals to x. Then this particular g function is said to be the inverse of fx, and it should be represented by f inverse of x. Is it to be clear? So this basic definition you have to just keep in mind, and according to that we have to just see the basic process. Now the student, very important thing, first of all we will just discuss the basic function sin x, cos x, tan x, and each and every function we will take step by step. And after drawing the graph, just we have to see about the domain and range, because the domain and range is the very important part for any of the functions. Because on the behalf of domain and range, student, we have to just check whether the function is given function is said to be bisective or not. So first of all we have to just discuss the basic graph of sin x, cos x, tan x, and one by one we will take each and every function. After that we will check whether the given function is said to be bisective or not. Suppose sometime the function is said to be bisective or sometime it is not said to be the bisective, then first of all we have to convert the function into the bisection part, means we have to make that function as a bisective function. After that we will just convert the inverse. Is it to be clear? So this particular phenomenon, this particular steps we have to just use here. So to find inverse, to find inverse, to find inverse of trigonometric function, trigonometric function, what things are to be required and what are the important steps we have to mention here. So to find inverse of a trigonometric function, the very first step, define, define the particular function, define the particular function according to domain and range, according to domain and range. Is it to be clear? So first of all, you can say that we have to just make the graph of this function, and that function will provide the domain and range here. Is it to be clear? So the very first step we have to use here. Now the second step, after drawing the graph and after checking the domain and codomain, students, just we have to check whether the function is said to be bisective or not. So in the second process, check whether the function is bisective or not. Check whether the function is bisective or not. So we have to check whether the function is said to be bisective. Bisective means whether the function is said to be 1 1 or on 2 or not. Is it to be clear? Suppose some of the cases we will get as bisective, but some of the cases suppose we are not getting the bisective function, then we have to restrict the domain. We have to restrict the domain so that the function will become the bisective. Is it to be clear? So if the function is not said to be bisective, then first of all we have to make the bisective, and for making of bisective, student, just we will convert the domain part. Is it to be clear? Let's see in the sin x how the particular domain is to be get changed and how the functions will become the bisective if it is not said to be bisective. Then we will see this thing with the some functions like sin x, cos x, tan x, how the particular function is to be get converted into bisective part. Now this is the second step. In the third step, in the step 3, just we are converting, if function is said to be bisective, then we will just define the inverse. Is it to be clear? If fx is bisective, if fx is bisective, then we will define its inverse. We will define its inverse. So always student, we have to use the three steps to calculate the inverse of any trigonometric function, or this is the general process in which you can take you can just use these steps for any kind of the functions. Here just according to the chapter we will discuss only the trigonometric function, but before you can say that you can use any of the functions, and suppose we have to just calculate the inverse, then we have to use these three steps. Means first of all we have to draw the valid graph if it is to be possible, and then we have to also check the domain and range of that function, and in second step we have to check whether the given function is said to be bisective or not, and after that suppose the function is not bisective, then we will restrict the domain, we will restrict the domain, and after that we will check we will make the function as bisective, and after making the bisective student we will define the inverse. On the definition of inverse there should be no problem, but before that we have to just check whether the given function is bisective or not. It is the very important step for us, and we will just make the any of the given trigonometric function into the bisective part. Then what we will do and how the process will be done, each and everything we will see carefully here. So student, pause the video to note it down these steps and this definition of inverse. After that we will take the one by one functions. Firstly we will take the sin x, then cos x, then tan x, and we have to just find the inverse, how the particular inverse is to be get obtained, and by using these three steps how the particular inverse is to be obtained. So we have to see one or two part carefully, then definitely student automatically you will learn the remaining part. Is it to be clear? So first of all we have to just define the inverse of sin x. Inverse of sin x. Is it to be clear? Sometime the inverse of sin x will be represented as arc of sin x, ARC. This word is to be used for the inverse also. Is it to be clear? So sometime it is also called as arc of sine. Is it to be clear? Arc of sin x will be again represented as sine inverse of x. Is it to be clear? Or you can just represent this sine inverse x like this also. So there are so many way in which you can represent the sine inverse x, but how the inverse will be defined, we will use the previous steps that we have to show. So basically let f of x should be taken as sin x. Now I think each and every student know very well about the graph of sin x, because this graph is to be used many of the times in the class 11, as well as this particular graph will be very helpful in the physics also, and some kind of physics we have to just see the basic graph of sin x. A basic wave type graph, you can just plot the graph. So here we will take the some values, and the graph of sin x would be like this. I think each and every student know very well this graph should be like this. Here you can take this particular point as pi by 2, this is pi, after that you can say that this is 3 pi by 2, and this is 2 pi, and here this is 0, this is plus of 1, and this is of minus 1. Is it to be clear? So I think each and every student know very well about the graph of sin x. Here you can just take the value as minus pi by 2, this is minus pi, this is minus of 3 pi by 2, and so on, minus of 2 pi. Is it to be clear? So this is the continuous process of writing the each and every value in the radian on x-axis, and output will be obtained on the y-axis as plus 1 and minus 1. Means the value of this particular function will vary from the minus 1 to plus 1. Now students, now we have to just mention the domain and codomain. So in this case you can just see that the domain of this function is said to be the R, because set of real number, because for each and every value on the x-axis definitely a graph will be available. So basically in this case you can just check whole x-axis is said to be the domain, and output and range, you can say that range is to be taken from minus 1 to plus 1. Here just we are taking the range, not codomain. Is it to be clear? So basically the output will be vary from minus 1 to plus 1. So we can just define the function like this. So this is the basic definition of this function. So now student, first of all we have to define the function, and I think each and every student know very well about the graphical part of the sin x. Now now you can just check the domain and range, and according to that in the second step, after defining the domain and range, we will check whether it is said to be the bisective function or not. So definitely student, in this case directly you can say that it is not said to be the bisective, because it is not said to be the 1 1. Why? Student, in this case, we will just check the 1 1 case. So how the 1 1 function will be defined? So there are so many definitions we have read in the last lecture. Suppose let f of x1, x1, x2 belongs to the R, where f of x1 equals to f of x2, then we will imply that x1 equals to x2 or not. So basically here you can just check the value. At 0 this answer will be 0. Here at pi this answer will be 0. Here 2 pi the answer will be 0. Suppose we have to make the mapping like this, and here just we have to plot the values 0, pi, 2 pi, then definitely student answer will be obtained as 0. So in this way we have to just make the diagram, and this is the case of many one. This is the case of many one. So easily you can just check with the help of taking of some values. Is it to be clear? But another ways to be also defined for the 1 1, and in the graphical manner we have how we will check whether the given function is said to be 1 1 or not. So basically for that part we have to draw any line parallel to x axis. We have to draw any line parallel to x axis, and student, you know very well, if we are drawing any line parallel to x axis, then definitely this particular line will be intersected many more points. That's why this particular function is not said to be 1 1, not said to be 1 1. You can just check by using this part or by using the concept of graph. Is it to be clear? How the graph will be checked whether it is said to be 1 1 or not? Then we have to draw any line parallel to x axis always. So if this line will intersect at more than one point, then definitely graph is said to be many one. So this is not 1 1. Now we will check for on 2 also. Now suppose it is not said to be 1 1, then definitely student the graph is not this particular function is not said to be the bisective function. Now we will also check for the on 2. So how the on 2 case we will check? So student, we have to check the range part -1 to 1, or you can take this part as codomain also. So this codomain is to be get checked, and we will check whether each and every codomain value has its pre-imagined domain or not. So definitely you can check any value from -1 to +1. Suppose any value you can take anywhere between this -1 to +1, then definitely in the left hand side the graph will be available. Graph available means you can just take the value, corresponding value as on the x-axis, means for each and every codomain value the pre-image will be existed in the domain, because the graph is said to be continuous here. So it is onto, it is onto, no problem in the onto, but there should be a problem in the 1 1. So student, if any function is not 1 1 but onto, then it is not said to be bisective. Now the thing we have to change the particular function into the bisective part. So now the second step we have to just apply here. Now student, this is not a bisective function. You can say that not a bisective function. This is not said to be bisective function. Now we will make this particular function as bisective, because just we want to calculate the inverse of this function, but the theory of inverse will say that this particular function is not 1 1, and it is onto, so it is not said to be the bisective. And in the case of inverse, the function should be bisective first of all, then definitely you can just define the inverse of that function, no problem. Now the student, what we will do to change this particular function into the bisective part? So basically we have to restrict the domain, means we have to take a certain interval, or we have to take a certain span in which the function should be 1 1 as well as onto. Is it to be clear? So definitely student, you can just see carefully here. Here just we have to see carefully, only just we are taking this part. Look carefully here, just we are taking this part. Is it to be clear? So from we are taking this graph from minus pi by 2 to plus pi by 2. We are taking this graph from minus pi by 2 to plus pi by 2. Means up to this part we have to take the graph only. Now students, some of the students says that sir, why we are not taking from this part to this part, this part to this part? Because there are so many symmetric parts are to be there. But student, there is a standard. There is a standard, means the things which are to be assumed worldwide are to be used in each and every book. Is it to be clear? That's why we are taking this particular middle part. Or suppose you are just starting compressing the graph from the both side in a symmetric manner. So suppose we are just start compressing the graph, then definitely we will just left the part which is 1 1 or onto, and you can say that the bisective. So here this particular function here you can say that this particular part from minus pi by 2 to pi by 2 we will obtain as the 1 because suppose we are just plotting this graph here to make the bisective function, then this is x axis and this is y axis, and just this is the minus pi by 2 and this is the plus pi by 2. Is that to be clear? So you can just check the graph. Means we are just taking this particular span from minus pi by 2 to plus pi by 2. Means this graph is to be included only. Now the particular function will become will be written as fx equals to sin x. But student, now the domain will be changes. So this particular function is to be defined from minus pi by 2 to pi by 2 to this value is minus 1 and highest value is plus 1 to minus 1 to plus 1. Means we have to just apply the certain restriction on the domain. Now after applying these particular type of restriction, you can check whether after applying the restriction the function is said to be 1 1 or not, on 2 or not. So again student, we will check the 1 1 and on 2 because now the function is to be get converted into the bisective part. So basically here you can just plot any line parallel to x axis. So definitely the line parallel to x axis now intersect exactly at one point, and in that case student always function is said to be by the 1 1. And for on 2 we will check the codomain, then minus 1 to 1, definitely all the values are to be occupied with the graph, that definitely now the function should become bisective. Means now it is bisective. Now it is bisective. Is it to be clear? Now the function will be ready to convert into the inverse. Means now you can just calculate the inverse. So basically student, in this particular kind of function sin x, whenever we have to calculate the inverse of sin function, then first of all we have to define the function. After that we will check whether the function is bisective or not. Now the function student, and one more important thing I want to say student, each and every function is not said to be 1 1 always. You can just check, and we will also check for each and every function. Then definitely no any function is to be there, any trigonometric function is to be there which is to be 1 1 directly in the defined domain R. Is it to be clear? So we have to just convert always the function into the 1 1 cases, and for this part we have to just start compressing the graph from the both side, and we have to take a certain span which is to be the 1 1 and on 2. So the definition will written here, no problem in sin x. This is the graph of sin x again, but this graph is to be made from where to where? Minus pi by 2 to pi by 2 to minus 1 to plus 1. Is it to be clear? So just we have to apply the certain restriction on the domain. So you can just say one important thing and one important definition for inverse of each and every trigonometric function, because no any particular kind of trigonometric function is automatically bisective, and we will see this part one by one here. Here just we are taking the sin x. Next we will take the many more functions also. So basically student, inverse of any trigonometric function will be always possible for only the restricted domain. You can say that. Means only for a restricted domain we can just calculate the inverse of a particular trigonometric function. Otherwise we will not said to be considered as the inverse of any trigonometric function. So first of all we have to just change the function into the bisective case. So now you can say that it is bisective. Now it is the bisective function. Now you can just calculate the inverse, and a very simple definition of inverse is to be there student. Let f of x equals to, we will take y, then what should be the x here? So definitely x will become sin inverse of y. Or you can just see one thing, in the case of inverse, now we will just calculate the inverse. So this is the last step. So we are just starting from here, then we will convert into the bisective. After that we are just calculating the inverse. Now the inverse. Now we will calculate the inverse. Is it to be clear? So inverse will be like this. You can say that f inverse x, you can write here sin inverse f x. Sometime student will get confused related to this part, how this x is to be get written. Student, there should be no problem to write the name of variable as x or y. You can take here fx equals to y, no problem, and this x will be written as sin inverse of y. But in which case? In this case only, not in this case. You cannot change this y and this is written as x equal to sin. In this particular domain, this should not be defined. So we have to keep in mind the domain part. The domain of any trigonometric function is to be very important, and after applying the certain restriction we have to just calculate the inverse. So student, here just we have to mention this thing. F inverse is to be defined from -1 to 1 to minus pi by 2 to pi by 2. Is it to be clear? So basically this thing is to be the very important. Now you can use the name of variable as x or y, there should be no problem. But suppose we are not mentioning this part, then definitely some problems are to be there. And student, for any of the function, the very important part is said to be the domain and range. Now the graph you can just make here. So if we have to make the graph of any inverse, then definitely student, we have to just put these values on the y-axis and these +1 or -1 on the x-axis. So this is -1, here this is +1, and here you can take the plus pi by 2, and here we will take the minus pi by 2, because in the case of inverse, just we have to revert the thing. This is to taken as y, and here just we have to calculate the value of x in terms of y. So this is said to be the sine inverse y. That's why we have to take these value on y-axis now, and these y-axis value on the x-axis to calculate the graph. Is that to be clear? Now, student, you can say that at particular pi by 2, this particular part is said to be the 1. So this graph should be like this. This graph should be like this. Means you can just plot the graph here, and just we are making the graph with another pen. Then definitely you can understand the thing. Suppose just we are plotting the graph here. Now you can check the graph. So again we will draw the graph again with the another marker. So basically student, in this case, suppose we are plotting the graph of this particular function, then you can say that this is said to be the plus pi by 2. This is said to be the plus pi by 2. This is said to be the plus pi by 2. This is said to be the minus pi by 2. Here you can take the -1, and here you can take the +1. So this graph is to be like this. This graph is to be like this. Means this graph will proceed like this here. Suppose we want to draw the many more sections, then you can say that this graph should be like this. Is it to be clear? So you can just plot the graph in a very systematic way. So this particular graph will represent the inverse of this sine inverse x. Is it to be clear? So definitely student, you can just able to make the graph somewhere it is to be required. Then you can draw the graph. On the behalf of graph part, you can just see the very important part. Suppose any bisective function is to be there, and we have to plot the graph of its inverse. Then one simple thing you can do here. And what simple thing you can do here? Just we have to make the mirror image in the line y equals to x. This is the very important concept for the purpose of drawing of graph, because we are drawing any line y equals to x, then we will take the mirror image of this part, and we will take the mirror image of this part. Is that to be clear? So suppose anywhere else we have to draw the graph of any inverse, then you can use this concept also. We have to make a line y equals to x, and the particular bijective function is to be get mirror image of that part is to be get in the line y equals to x, then you will definitely get the graph of inverse. Is it to be clear? So definitely student, in this particular whole process, how the inverse of function sin x will be obtained, you can see. So first of all, we have to define the function. We have to know about the domain and range. After that, we will check whether it is bijective or not. If it is not bijective, then first of all we have to become the function as bijective, and for this part we have to just restrict the domain. We have to just restrict to domain, means for the restricted domain the inverse of any trigonometric function is to be possible, otherwise no possibility of inverse is to be there. Now after changing this particular function into the bijective part, definitely student, we have to find the inverse, and a very simple theory in inverse we have to use here, and we will use the same phenomena as we have to done in the previous lecture functions, where suppose any y is to be written in form of x, then just we have to written x in form of y, and that should be called as the inverse. But before that we will check whether it is the bijective function or not. So in the similar manner student, I will tell each and every inverse of the given trigonometric functions. Here just we have to take the inverse of sin x first of all. So basically at last we have to make the table. In that table student, we have to just mention this thing, because this particular part -1 to 1 is said to be the domain of inverse, and minus pi by 2 to plus pi by 2 is said to be the principal value. This is known as the principal value. So standard values are to be there. That's why the name of this part is not said to be the range. Always we have to just mention this part as principal value. Is that to be clear? So in this way we have to calculate the inverse of each and every function. So note the whole thing, student. And now we will take the next function sin x. After that sin x we will take the cos x, and we will again do the same process, and you can just see the answers how the particular part is to be get converted here. Is it to be clear? So the next part we will take. Before that, pause the video to note it down the whole thing, student. Next, cos x we are taking here. Cos x we are taking here. So in the second part, just we are taking the inverse of cos x. Inverse of cos x. Now it is again, you can say that it is to be written as arc of cos x, or sometime you can write like this cos inverse x, no problem. So either of the notations you can use here to represent the inverse, and somewhere in the examination, suppose cos inverse is not to be written, and in place of this part arc of cos x is to be written, then definitely both the parts have the same meaning. So there should be no confusion related to the notations part. Is that to be clear? Now again, student, I think each and every student know very well about the graph of cos x. First of all, we have to define the basic function fx equals to cos x. So let fx equals to cos x. And student, for the cos x function, the graph should be like this. I think each and every student know very well. This is y axis, this is x axis, because here you can just say that at 0 the value will be 1, and the graph should be proceed like this. The graph should be proceed like this. Is it to be clear? So this is plus 1, this is minus 1. Is it to be clear? Here this is 0, and you can say that this is pi by 2, this is pi, and you can say that this is said to be the 3 pi by 2, and next you can take the 2 pi like this. Similarly, in this part this is minus pi by 2, here you can take minus pi, and so on. Is it to be clear? And the highest and lowest value will be plus 1 or minus 1. I think you know very well. So now you can just think about the domain and codomain. So basically, for each and every value on x axis, you can say that the graph will be available. So the domain of this function should be taken as the set of real number, and this particular part is said to be the plus minus 1 to plus 1. So this is the basic function cos x, and we have to just know about the domain and codomain, because student, these are the very important section here. On behalf of the graph, you can just write down the domain and range part, you can say that, or you can just say this is the codomain also. Now the function is to be defined here. First of all, the basic definition of functions you can see here, and I think you know very well about the graph of cos x. Now student, we will check, we have to just find the inverse of this cos x. Then definitely we can check the very important part, and the important part is that student, we have to check whether it is said to be the 1 1 or not, onto or not. Is it to be clear? Because the function is said to be bisective, then directly we will convert fx equals to f inverse x equals to cos inverse x, and we have to just make this particular part as the domain, and this is the codomain. But before that, before converting, we have to check whether it is said to be bisective or not. So the 1 1 case, first of all we will check the 1 1 case. So definitely you can draw any line parallel to x axis. You can draw any line parallel to x axis, then definitely this particular line will intersect the graph at more than one point. Means at many more points this particular line will be intersected here. So definitely in this case, this is said to be the many one case. So this is not 1 1. This is not 1 1. You can just check with the help of this particular concept of drawing any line parallel to x axis. There should be no calculation you can do, and you can just also make the mapping like this. Is it to be clear? And you can see the graph here at 0, at pi by 2, at 3 pi by 2, and many more pi by 2 will give the answer as 0. So this is said to be the many one function. This is said to be the many one function. So you can just draw the mapping here, and easily you can just draw the drawing the line parallel to x axis, then definitely graph is to be checked whether it is said to be 1 1 or not. Now you can say that this particular function is not said to be the bisective. This particular function is not said to be the bisective. Now student, we will also check for the onto. Onto means we will check for the codomain pre-image in the domain. Means for each and every value that should be related to the codomain has a pre-image in domain or not. So definitely in this case, I think there should be no problem, because the codomain will be given from -1 to +1. So you can take any value in this particular region, then you can check the graph. in both side you will get the graph, and you will get the graph, then definitely corresponding value of x you can just find in the set of real numbers. So definitely there should be no problem in the onto. It is onto. It is onto. But you can say that it is onto, but it is not 1 1. Then definitely it is not a bisective function. Again, it is not a bisective function. So if it is not a bisective function, then first of all, to calculate the inverse, we have to become this function as bisective. And for this part, student, we have to just restrict the domain. So how the restriction of domain is to be get applied, we have to see this thing. So which part is to be taken here? We have to see this part. So now I will just take this part. I will take this part. Is it to be clear? So definitely, student, if we are taking this part of graph only, then you can say that this is taken from 0 to pi, means 0 to pi you can just take this graph. Is it to be clear? So if only this particular span of this particular graph is to be taken, then and the remaining part is to be get removed, then there should be no change in the definition part. It should again remain as the cos x, no problem. But here domain will be changes. Here the domain is to r. Basically, the domain of this whole function should be set of real number. But suppose we are drawing the graph from this part to this part, then only we have to write the domain from 0 to pi only. Is it to be clear? So definitely, student, we have to make the graph to make the function bisective. Then this particular graph should be like this. This particular graph should be like this, and here this particular value is set to be the pi, and here this particular value is set to be 0, and here this particular value is set to be pi by 2. Is it to be clear? So we will just draw the graph, and the part of this graph is to be, means only the span of 0 to pi we have to make. Now you can just check whether it is set to be 1 1 or bisective or not. So definitely, student, again this value is set to be the +1, and this lowest value is found to be the -1. So now the function will be remain same. So now the function will be written as cos x, no problem. But here the domain should be written from 0 to pi to -1 to +1. Now we will check whether it is found to be the 1 1 or 1 2 or not. So definitely, student, in the case of 1 1, again we will draw any line parallel to x axis. Again we will draw any line parallel to x axis. So if we are plotting any line parallel to x axis, then definitely the graph will be intersected at exactly one point, then it is said to be the 1 1. And onto means we have to check again the codomain, means for each and every codomain value in the right hand side you can just check the graph is to be available, means corresponding value of x is to be there in the domain. So definitely it is said to be bisective. It is bisective function. Now the function will become bisective. Now easily, student, you can just define the inverse of this function. So again the symmetric steps we have to use to cos x also, as you have to see the basic step we are using for the sin x. So in the similar manner, student, we are using the step for cos x, and many more trigonometric functions are to be also there. So same type of working phenomena we will just adopt for the remaining of the functions also. So now student, we will just calculate the inverse. So now the inverse you can just tell, then inverse of this function will be defined as f inverse of x will become cos inverse x. But this is not said to be the proper answer, student. But before writing, after getting the bisective, you can write here cos inverse x, no problem. And on the behalf of name of variable, again there should be no confusion to you, because you can use your y also, you can use your x also, you can use your z also. But what should be x and y we have to define. Then we will write f inverse is to be taken from -1 to 1 to 0 to pi. Just to be clear, because in the case of inverse, this codomain part will become the domain and domain will become the codomain. Is it to be clear? And suppose we want to plot the graph, of this function, then easily you can plot the graph, no problem. So this is x axis and this is y axis. So we have to take this 0 at 2 pi. So this is 0 and this is pi. And here you can just take another value pi by 2 here, because at pi by 2 this is 0, and this value +1 and -1 we have to taking here. So this is +1, sorry, -1, and this is said to be +1. Is it to be clear? So basically, student, here this graph should be like this. This particular graph means we have to make a line y equals to x, then we will take the mirror image of each and every part. So definitely if we will make the graph, then graph should be like this. Graph should be like this. Is it to be clear? So this particular graph is to be obtained here. At this particular pi, this is -1, and at 0, this is 1. So no problem. So this particular graph you can just make for the cos inverse x. Is that to be clear? So how the particular inverse is to be get obtained and how it is to be get defined, student, you have to see carefully the things. How the functions will become bisective, and for the making of bisective part, how the restriction of the domain is to be get applied, and after that we have to make the inverse of that function. So in this way, each and every trigonometric function we will take one by one, student, and we will just obtain the inverse. And finally, we have to learn this thing. This is the very important part. Inverse you can write here, cos inverse, sin inverse, no problem, but we have to mention this part and how this particular part 0 to pi, and in the previous sin inverse x we are saying that the principal value is to be obtained as minus pi by 2 to plus pi by 2 we will obtain. So these things are to be the very important case. So definitely, student, we have to keep in mind the things, and according to that we have to just learn the things, so that easily you can just simplify the inverse trigonometric functions and you can do the proper calculation. Is that to be clear? So student, pause the video to note it down the things, and the next function, student, we will take in the next video. Before that, you have to just focus on these two functions now, and you have to just do the practice of drawing the graph again and again. Check the one on two again. Again, there should be a chance where we have to just learn the concept of bisective function and to calculate the inverse. How the particular process is to be get used. You can use these things here. Is that to be clear? So after reading the part, just we have to make the graph, and one by one we have to use the particular steps. Means first of all we have to define the proper function. It is bisective or not, we have to check. If it is not bisective, then become the bisective part, and then after we have to write down the inverse. Is it to be clear? So student, in this video just we have to initialize this chapter, and basic two functions, inverse of any two functions sin x or cos x, we have to define here. Now the further functions tan x, cot x, sec x, cosec x we will take in the next lecture. But before that, you have to just see the video carefully, and you have to do the practice of these parts, because this practice will uh, feel the particular chapter. Otherwise, if you are not doing the practice and if you are not knowing this part, how this particular part is to be get become, then definitely you cannot understand the concept. Is it clear? So student, a very basic and a very simple chapter is to be there, but some logical part is to be included here. And sometime in the examination, suppose we are not knowing this logical part, then definitely you will face the problems, and generally the answers are not so too long, and questions are to be asked in the examination from this chapter, but very small type of questions and a logical type of questions are to be asked. So we have to just keep in mind the domain, codomain, each and everything related to the inverse trigonometric functions. So thank you, student. In next part we will meet with the some more inverse of trigonometric functions like tan x, cot x, sec x, cosec x. Thank you.